So in the last videos, we had a very clear discussion up to Q data structure. Now in today's session, we are going to talk about another data structure. So another theoretical concept, which is nothing but bit manipulations. So what is mean by bit manipulation? Let me give introduction for this. So here, generally, it is used to perform. It is used to perform binary. It is used to perform operations on binary numbers. If you want to perform the operations on binary numbers, we will go for these bit manipulations. The biggest advantage is nothing but performance. Performance of the application will be improved once if we use these particular bit manipulations, I mean binary operations, then these binary operators, then automatically the performance of the application is going to be improved like anything. So slowly efficiency efficiency also will be improved. Efficiency also will be improved. This is nothing but the advantages what we have when you are working with these binary numbers, binary operators. Okay, so here these bitwise operators, so in bit manipulations, so binary in bit manipulations, operators are working with working with binary numbers directly, because we have bitwise operators will be there. Those operators are going to work effectively on binary numbers. Suppose if you take plus operator, if you are giving some inputs to evaluate a plus b or 2 plus 3, something like that, so 2 will be converted. Best example here itself, I will take 2 plus 3. Sir, 2 and then 3 and then plus. So all these, all these three operands and operators, operators should be converted into binary. But if you take any bitwise operators, something like 2 and 3, do you know only 2 and 3 are required to convert into binary? Why? Because this and operator will purely work on binary numbers. So we are not required to convert manually. That is nothing but the biggest advantage what we have. And in general, we have number systems are there. Means what? Sir, if you want to represent a digital number system, if you want to represent a digital numbers, so we have the following types of number systems are there. The first number system what we have here is decimal number system, which we are going to use decimal number system. So what is the digits that you are going to get for these? We will get from 0 to 9. What is the base of this number system? 10 is the base. What is the representation for this? There is no representation for this decimal number system. And the second one what we have here is octal number system is there. Okay, we have octal number system is there. So what is mean by this octal number system? The allowed digits are 0 to 7. What is the base of this number system? It is going to take only 8 digits. What is the representation for this? So it is prefixed with, sir, 0 something like that we are going to take. So what about next one? We have hexadecimal number system is there. In the hexadecimal number system, what digits it is going to take? 0 to 9 and A to F. So what will be the base? It is nothing but 16. And it is prefixed with 0 small x or 0 capital X, like that we have. And the last one, we have binary number system is there. So what is this binary number system? The allowed digits are 0 0 and then 1. Okay, What is the base of this number system? 2. So it must be prefixed with either 0 small b or 0 capital B. These are nothing but what are the various number systems what we have. Okay, so how to convert all these things I will explain. Up to this, do you have any doubt?
No, sir.
Right. Sir, here I will explain how to convert decimal to binary conversion. How you can able to convert a decimal number system into binary number system. I am going to explain. There are two methods are there. In the first method, what is the first step is nothing but we have to divide the number by 2. We have to divide the number by 2. Sir, where it gives a quotient, okay, and a reminder. So what we have to do, we have to store the reminders. Okay, we have to store the reminders in a container. We have to store the reminders in a container, maybe array or list, something like that. Next, we have to print the stored values. We have to print the stored values in reverse order. Okay, we have to print the stored values in the reverse order. If you want, I will take one example. Suppose if you take number is equal to 13, if you perform division operation, what output we will get? Sir, we are going to get a quotient and then we will get remainder. Let us take the first division operation, like 13 by 2, because we have to divide with 2 only. So what is the quotient that you are going to get? 6. What is the remainder that we will get? 1. And again, whatever quotient you got, you have to again divide with 2 until that number will become 0. So 6 by 2 means what? You are going to get quotient as 3. So remainder is nothing but what? 0. And what is the quotient that we got? 3. 3 by 2, again we have to calculate, where quotient is 1, remainder is also 1. Then 1 by 2 you have to take, quotient is 0 and remainder is nothing but what? 1. So what is the final output? The answer what we are going to get is in the reverse order you have to take 0 1 0 1. But technically how it is going to work, I will show you with the help of example. Here you can see the given number is nothing but what? 13. So first you have to divide this number with 2. So what is the output? Sir, 2 6s are 12, right? So what is the remainder that we are going to get? Remainder is 1. That's why I captured here. Next 6 you have to take it as quotient. Then again divide with 2. Sir, 2 3s are 6, right? What is the remainder? 0. So that we have captured here. And what is the next value? So 3 we have to take, again divide with 2. So 2 ones are 2, the quotient is nothing but 1. Okay, so remainder is also 1. Then take that 1 and again perform with 2. So 2 zeros 0, remainder is nothing but 1. So these remainders you have to write in the reverse direction. That's why the output what we got is nothing but what? 1101. Like this we have. Okay, this is nothing but what we have. Okay, I hope you people got a clear idea the first method, how you can able to convert a decimal number into binary. Everyone feeling comfortable up to this? Please confirm.
Yes, sir.
Right, right. So what is the next method? That is, we have another method is also there. What is the another method? Here is method 2. In this second method, we are going to take 8421 code. Okay, we can find a binary equivalent. Okay, so binary equivalent for the given number in the form of 8421 code. 8421 code. Just for your understanding, I have taken only 4 bits. Suppose if a big binary number is coming, you have to take 168421, 328421, 32168421, like that. You can increase the powers in the left side. Now let us take the same example. What is the example that I have given? N is equal to 13. So 8421 code is there. By adding which numbers we are getting for 13? So 8 plus 4. 8 plus 4 is nothing but 12. 12 plus 2, 14. But we are not required this 14. So take the 0 in the place of 2. Now 1. Now if you add this, that means 8 plus 4 plus 1, the output what we are getting is 13. That's why the binary equivalent is nothing but what? 1101. In the previous method also, we got the same output for this. This is the way how you can able to convert a decimal number into binary form by using these two methods. Is these two methods are clear for you people? Please confirm. Clear up to this?
Yes.
Right. The second one, the next one, what we have, okay, binary to decimal conversion. Binary to decimal conversion, we have to see. Binary to decimal conversion. So in this also there are two methods are there. What is the first method? In the first method, first we have to read the symbols. We have to read the symbols from right to left. Okay, we have to read the symbols from right to left. What is the second process? We have to multiply each bit. We have to multiply each bit. So with 2 to the power x, 2 to the power x, where the x values are 0, 1, 2, 3, and so on. Okay, third one, we have to sum all these values. We have to sum all these values. Okay, so which is nothing but our result. That is nothing but result what we are going to get. Example, let us take the same previous example, whatever we covered, 0, 1, 0, sorry, 1101. Okay, so take the last digit from which from which corner to which corner you have to read, right to left. So that means first we are going to take 1. So 1 into 2 to the power 0 we have to take. 1 into 2 to the power 0. 1 into 2 to the power 0. What is the result? It is nothing but 1 into 2. Sorry, 1 into 1. The output what we will get is 1. Next bit is what? 0. 0 into 2 to the power 1 we have to take. So 0 into 2 to the power 1 is what? 2. The output what we are going to get is 0. Now 1 into, so 2 to the power 2 we have to take. What output we will get? 1 into, sir, 2 power 2 is nothing but 4. What output we will get? 4. Next 1 into 2 power 3 we have to take. So what is output? 1 into 2 cube means 8. So 1 into 8 will become 8. So if you add all these things, what is the output that we are going to get? So which is nothing but 13. So the binary decimal equivalent for this is nothing but 13. This is method 1. Method 2 is what? Same 8421 code. By using 8421 code, it is not completely 8421. If more bits are there, you have to take 2 to the power. Okay, so by using 8421 code, we can find so decimal representation for the given binary value. Sir, how to take? Let me take one example for this. So same example I will take 1101. How to represent? Sir, 8421 code, right? This is nothing but 8421. In which places we have 1? That you have to identify. In which places we have 1? So 8 plus 4 plus 1. What is the output that we are going to get? 13. Suppose if you take 1010, in which places we have 1? Those numbers you have to take, which is nothing but 8 plus 2. The result is a 10. This is nothing but the second method what we have. Up to this, do you have any doubts? Please confirm. Clear?
Yes, sir.
So this is the way in the number system, how you can able to convert from one form of data to another form of data. That is decimal to binary and binary to decimal, how you can able to convert. So the next concept in this is bitwise operators. In a every programming language we have these bitwise operators. What is the purpose of these operators? It is a special operators, so that are existed in almost all the programming languages. In every programming language we have these bitwise operators, and it is an efficient way, it is an efficient way to work with, to work with any application, because I just now I told the performance is going to be increased, and it is very fast. Okay, it is going to very fast when compared with other operators, when compared with other operators. So its evaluation will become very fast. Okay, and it requires so linear time, it requires linear time for execution. That means almost constant time, I can say almost it is going to take a constant time to execute. Okay, next, and after that it is very easy to implement these bitwise operators because it is a language level concept. So total we have 6 bitwise operators are there. First one is bitwise, and symbolically we are going to represent like ampersand symbol. Second one is bitwise or, symbolically we are going to represent like this. So third one we have bitwise exclusive or, symbolically we are going to take it as a cap symbol. Okay, fourth one, so we have bitwise left shift is there. Okay, bitwise left shift, so symbolically it is represented as a double less than symbol. And we have right shift is also there, so symbolically it is represented as like this. And third one we can take even complement also. How to represent the complement like this we can take, these are nothing but the 6 types of bitwise operators which are available. Okay, now I will take one example how you can able to represent these bitwise operators with respect to calculation, I will tell. But before that, what is a truth table? Suppose if you have value 1 is there and value is 2 is there, if I am taking value 1 and value 2, so what will be the result? And if I am taking value 1 and so sorry, or value 2, what will be the result? If I am taking value 1, so cap value 2, what will be the result? We will see. Because these are going to work with binary numbers, I will take 2 binary numbers combination. The first one is I am taking 0 0. Okay, so first binary number is 0, second binary number is 0. Next I am taking so 1 0, next I am taking 0 1, next I am taking 1 1. Like this I am going to represent. 0 0 means what about and value? 0. What about r value? 0. What about cap value? 0. So in the case of and operation, if both bits are 1, sorry, both bits are 1, then only result is 1, otherwise the result will become false. Okay, next, so in the case of 1 0, in the case of and we will get 0, because so for and operation both the bits must be 1. In the case of or it will become 1, because if any one bit is true, result is true. That means if any one bit is 1, result will become 1. Even in the case of cap also it will become 1. So what about 0 1? It is also almost the same, right? We are going to get like this. What about both? One means and operation is going to return 1, so or operation is going to return 1, and exclusive or is going to return 0. Exclusive or means, remember carefully, so in the case of exclusive or, if both the bits, if both the bits are in different direction, so then only, so then only the result is true, that is 1, else it will become 0. That is for 1 1 and for 0 0 result is 0. Okay, for 1 0 and for 0 1 the result will become what? 1. Like this we are going to get. So these are nothing but the basics of bitwise operators what we have. In addition to that, there is left shift right. What is the formula? Direct formula I am taking. The formula for left shift is, if you take a left shift of b, it is equivalent to a into, okay, a into sir 2. How many times we have to take b times? So right shift means we have to take a right shift of b. You can take a by 2. How many times? So b times you have to take. Okay, then so what about the complement? What about complement? Complement means if you take, so complement of any number n will become minus of n plus 1 is the result. These are nothing but what are the various bitwise operators which are available. Sir, everyone feeling comfortable up to this whatever I covered?
Yes, sir.
Right. Yes. So the next one, what we are going to discuss here is advantages. Advantages of these bitwise operators. I'm not taking any examples because you are already familiar with this. Advantages of bitwise operators. The first advantage, speed of the application is going to increase, and you will get a space optimization, because the time and space are very important in our data structures, right? That's why we can able to decrease the amount of time, and then we can decrease the space also in this. So easily we can perform bit manipulations. What is mean by bit manipulations? Within few minutes we will see some applications, and the code will be simplified. Code simplifications you can able to get. So next, and after that, readability. Okay, readability will be improved. The readability of the program is going to be improved. So next, even we can use these things in the data encryption. In the data encryption process also we are going to use these bitwise operators. These are nothing but what are the applications what we have, I mean advantages. Now I'm going to explain four exercises, four example programs, so which is going to work based on these bitwise operators. What are the applications here is, listen carefully. The first program I will explain even number or odd number calculation. Okay, I want to check whether the given number is even number or odd number. By using which operators? By using the bitwise operators I am going to evaluate. And second one, I am going to take, so swapping off. Okay, swapping off, so two numbers I am going to take swapping off two numbers by using these bitwise operators. Next, and after that, lower case to uppercase conversion, lower case to uppercase conversion, and also so uppercase to lower case conversion. These four programs I am going to explain with the help of code. Sir, if you are clear with up to this, I will explain how you can deal with these things, how you can work with these applications by using bitwise operators. Are you clear with this theoretical part whatever I covered?
Yes, sir.
Right. So let us take the first application. What is this first application? We have to check whether the given number is even number or odd number. Sir, how to decide? So first I will write a few examples. If you take the number 0, what is its binary equivalent? 0000 is the binary equivalent. If you take 1, what is its binary equivalent? 0001. If you take 2, what is its binary equivalent? So 0010. So if you take 3, what is binary equivalent? 0011. If you take 4, what is its binary equivalent? 0100. If you take 5, what is its binary equivalent? um, 0101. Like this we are going to get. If you take 6, so 0110. If you take 7, 0111. Like this we are going to get. This is nothing but binary equivalent for certain numbers. Now by seeing these binary numbers we can get one clarity. So when we can say a number is even number, and when we can say a number is odd number, can you please tell me based on which we can decide, sir? Any clue in these numbers? Please confirm.
Sir, last digits of every number should be one. It is all that.
Yes, good logic. Okay. Is it MSB or LSB? One second, sir. Please wait. Yeah, sir, please tell me, is it MSB or LSB? Last bit. Yes.
LSB.
If LSB bit, if LSB bit is so 0, then it is even number, right? And if LSB is, if LSB bit is 1, then it is nothing but what? Odd number. Like that we can able to find. Okay, now I am going to write one logic. First I will explain with the help of diagram. Please listen, it is not MSB, it is LSB. Okay, right, listen carefully. Sir, if I have a number is equal to, okay, if I have a number is equal to something like 5, what is its binary equivalent? So 8 4 2 1, right? If I perform AND operation with 1, all bits I am taking 0, I am performing AND operation with 1. Sir, what will happen? 1 and 1 will become 1. In all the remaining bits we will get 0. I think no need to consider last 3 bits. Why? Because AND operation with 0, definitely it will return 0. So that's why, what is its value, sir? 1. Then we can say it is odd number. So n is equal to 6. If you take 6, what is its binary equivalent? Sir, 8 4 2 1, like this we have. If you perform AND operation with 0, what will happen? Sir, definitely if MSB LSB bit is 0, you will get 0 only, right? Then can I say, is it even number? Yes. So the logic here is, if the given value performing AND operation with 1, we have to perform AND operation with 1. If this result is equal to 0, then so result is even number, else the result is odd number. Based on this, we have to write the code. Sir, if the concept behind this application it is clear, means I will execute this program. Is it clear?
Yes, sir.
Everyone please confirm clear.
Sir, it is only valid for the integer objects
It is
bitwise.
only for integer. We will check whether the given number is even number or odd number only for integers, right?
Suppose, sir, we are taking any string object.
For
So
string
in that,
object, how you can say even or odd? We can't write.
no, sir. I am not talking about the odd and even.
Mhm.
My question is, if we are taking something string object in backend, we must be converting 10 means machine code.
See,
So
that is
which
reason why we have this ASCII values concept is there, right?
okay, okay.
Got it? If you have a
Yeah,
string called ABC, individual characters will be converted into by ASCII code. Then again, it is a number, right?
okay.
Then our
Yes.
problem will get solved. Okay. Don't worry,
Uh,
we have that application. Lowercase to uppercase application is there, right? There we are working with the string and bitwise operators. I will demonstrate.
mean, means sir, backend they means on working on the word means ordinary values, ASCII values, which are
Yes. ASCII value or ordinal value or Unicode, all the terms are same. Okay. Right. So I will write a program for this. Listen carefully. So I am taking a new Python program. So I will save this Python program in the test folder. Now listen. So I am defining a function. What is that a function here is even or odd, like this I am taking. It will receive a number n. If the value of n percentage 1 is equal to 0, then we are going to return the message saying even number. Else I am going to return a message saying odd number. Like this we are going to take. Now for each I value in the range of up to 11, means what? 0 to 10 it will execute. I will print that number, and I am calling even or odd function, even or odd function by passing the I, and the separator is equal to I am giving tab space. That means with one tab space it is going to print the total result. Let me run py space test.py. I am giving, have you observed? 0, is it even number or not? Yes. 1, is it odd number or not? Yes. 2, is it even number or not? Yes. Like that it is going to print whether the given number is even number or odd number. I think you got clarity how this application is working. Everyone feeling comfortable up to this?
Yes, yes.
Let us take second program. What is this second program? Sir, swapping of two numbers. We need to provide two inputs as the result, I mean input. We have to calculate the swapping. Swapping means what? Something like interchanging. Let us take, I'm reading the value of a from the user, like enter a value I'm taking. So then I'm going to read the value of b. So I'm going to print enter b value. Like this. Next term, I will print the message saying in the formatted string before swap. Before swap, the value of a is nothing but a, and the value of b is nothing but I am printing b. Okay. So after that, I am going to call swap function by passing a comma b, and the same print statement I am taking again with the message after swap. So what is that swap function is going to do? It will interchange the values. How to change? Okay, how to change this one? Very simple. I think better if you print these two statements here itself. It will be good, because again pass by value, pass by reference concepts will trigger. So what is the logic here? I think in the demo sessions itself we covered very clearly. So how it is going to work? Sir, I am going to take a is equal to a cap b, b is equal to a cap b, a is equal to a cap b. This is the formula. If you want, I will take one example so that you can get clarity. So consider the value of a is equal to I am taking 4, and the value of b is equal to I am taking 5. What is the binary equivalent of 4? So 8421 is the code. And what about this one? So 8421 is the code. Now first instruction is a is equal to a cap b. What is the latest value of a? 0100. What is the latest value of b? 0101. So what about the cap operation? Here 1, here 0, here cap, right? 00 will come. This is nothing but the updated value of which one? A value 0001. Sir, next what is the second line? B is equal to your a value is 0001, and your b value is nothing but what? So 0101. Latest value we have to take 0101. Perform AND operation, sorry, cap operation. Sir, 0100. This is nothing but the latest value of b, 0100. What about the next one? Again a cap b. What is the latest value of a? 3 zeros followed by 1. Latest value of b? Sir, 0100. Like this we have. So 1010, like this we are getting. This is nothing but what is the value of a? So this one will become 0101. What is its decimal equivalent? It is 5. What is its decimal equivalent? It is 4. Sir, before it is 4, now it is 5. Before it is 5, now it is 4. Like that we can able to interchange the values. Sir, how it is working in the background? Is it clear?
Yes, sir.
Please confirm everyone. Clear up to this? Right, sir. So let us execute this program and cross check. Let us give the same inputs like 4 and 5 I am giving. Before swapping 4 5, after swapping 5 4. Like that we have. This is the way how you can able to swap two integer values by applying this logic. I think everyone got full-fledged clarity. Okay. So what is the next application here? We have lowercase to uppercase conversion and uppercase to lowercase conversion. Let us see how we can able to perform this activity. Okay. Right. So I'm reading a name from the user. Since it is directly string value, I'm reading enter any name. Okay, enter any name in lower case because we are working with lower case to uppercase. I'm taking a list. Okay, I'm taking a list. Let us take it as capital L empty. For each character in the name, okay, it is going to fetch one by one character from the name. And what we are going to do is we are appending into the list. But before appending, I am going to apply some formula. What is that formula is? Listen carefully. Suppose if the given input is something like ABC, okay, in the lower case I am taking. So your A value, you have to convert it into ASCII value. What is ASCII value for A? 97. Sir, how to find ASCII value? In Python, we have one function is there with name ORD, which will find ASCII value of the given character. Then, sir, we need to convert this ASCII value to 65. Why we need to convert to 65? Because its ASCII value is a capital A. So for doing this, we need to use bitwise operators. How I am going to do this is, first we need to take 97 in binary representation, and there is one special number is there called 32. You have to take these two values in the binary. Okay, let us see how you can able to do that. I am going to search it in the Google. Okay, what is its equivalent values? I need to search. So decimal to binary converter, decimal to binary converter. Okay, so what is the number that we are going to give? 97. Can you please convert it into binary? Sir, what is the number that we are getting? Sir, it is 1100. Okay, again 001, like this we are getting. Sir, same thing, can you find for 32? For 32, what output we will get? Let us see. Sir, what is the output that we are getting? So 100. Okay, then we are getting 000. Am I right? So 100 000. Since it is having only how many digits, sir? So 6 digits. We have to move like this, and that pending digit you have to take it as 0 because for evaluation purpose. This is nothing but what we have. By applying which operation we will get ASCII value for 65? We need to get. Let me perform AND operation. Sir, here you will get 0, here 1, here 0, here 0, here 0, here 0, here 0. Let us perform OR operation. So here 1, here 1, here 0, 0, 0, 0, 1. Let us perform cap operation. 1, 0, so 0, 0, 0, 0, 1. Now I need to see, okay, by performing which operation we are going to get 65. So let us again take this one and find the ASCII value for 65. Sir, what is the output? 100 000 1. Sir, it is nothing but which one, sir? Last one, right? So we have to perform which operation? Cap operation. By performing cap operation between 95 so and then 32, we are getting the output 65, which is nothing but ASCII value of A. Now I am going to write the program. First we have to take ordinal value of CH. For that you have to perform cap operation with 32. Whatever result you are getting, you have to convert it into character. This is nothing but what we have. Now in this list, all the uppercase characters will be there. Can I join this? Yes, we can use join method to join this. By using empty string, I am going to join each and everything, where you will get the complete result in uppercase characters. Let us execute this code. So I am running the Python program. Enter any name in lowercase. I am giving my name in the lowercase. Sir, is it converted into uppercase or not? Yes. This is the way how you can able to do. I think you people got full-fledged clarity how this application is going to work. Friends, please confirm any doubts up to this whatever I covered.
Yes, clear.
Right. So the next one what we have, the reverse operation. So what is that reverse operation? How to convert uppercase to lowercase? It is also same thing, sir. It is also same thing, but directly I am explaining the logic. We have to perform OR operation between this. That's all. So we have to give the data in uppercase. If you perform OR operation, you will get the result. If you want, you can see. So enter any name in uppercase. I am giving Python. Is it converted into lowercase? Yes. Take the binary numbers of these things and calculate, you will get the result. This is the way the power of bitwise operators to improve the performance of the application. Okay. So I think you people got very clear clarity about this bit manipulations, whatever we have. Any doubt?
Sir, if you are passing something title, then what happened?
If you are passing
Title
title,
in title form.
no, I mean you are asking both lowercase and uppercase.
Suppose we are passing input as a title character.
That's what, sir.
What will
Character means
what
first character
is
of.
what is the accepted output? I ask.
Sir, I am not getting your question properly. Tell me the input, sir.
Any the Python in title means title is one type upper lower title.
Okay, if you are giving like this,
Yeah.
yeah, that's what I'm asking. So it is going to convert it into lowercase.
Okay.
It will do anything, any operation. So here already the data is in lowercase. Which operation we are performing? OR operation. Then whatever result is there, same result you will get, right? Whether it is 0 or 1. Got it?
Yes, sir.
Yeah, try to take the ASCII code characters, then you will get more clarity. Okay. Any doubt up to this?
Hmm.
Clear, sir?
Yes, sir.
Right. So that's all about today's session. Sir, tomorrow we have class. Okay, tomorrow maybe 6 to 7:15 like this only I am going to take. So tomorrow I am going to finish this sorting and searching algorithms summary, and then I am going to introduce dynamic programming. What is mean by dynamic programming? How you can able to solve the programs by using dynamic programming, and this linked list, circular single linked list, circular double linked list. These things I will explain. Sir, tomorrow at sharp 6 o'clock I will start the class. Okay. So 6 to maybe up to 7:15 or 7:30 I will take. Half an hour is sufficient for this sorting and searching algorithms summary and dynamic programming, and rest of the 1 hour the finishing of circular single linked list, circular double linked list we will see. Okay. Right, sir.
Okay.
I will upload these running notes within few minutes. You can download. Thank you.